This video is over function versus relation. A relation is a rule between two sets. And these two sets are domain and range, or input and output. A function is a relation where there is one domain to one range, or for every output for every input you have one output. So you can think of a function as walking into a store, and you see two pins. A function states that these two pins, this blue pin can be $1 and this purple pin can be $1. Okay, that's okay. But a function cannot be where this pin is $1 and $2 at the same store. Okay, so one item cannot be priced two items. So think of these pins as your domain and then your range as the price tag. So multiple items can have the same price tag. One item can't have two price tags, and that's what we mean by going from one domain to one range. One item, one price. It's not one item, two prices. That would be actually a relation. So let's identify domain, range, and tell if it's a function. Okay, so there's many ways you can display a relation. You can have a map, you can have ordered pairs, a graph, or you can tell by an equation. And we're going to look at all of these in one video. So let's look at the first one. We are going to look at a map. Okay, so our map shows this. Our domain, which I do domain colon, is 1, 2, 3, 4. Okay, so this side, that's our input. Our output, our range, which where is our domain going to, is 2, 4, 6, and 8. And as you can see, 1 is going to 4, 2 is going to 6, 3 is going to 8, 4 is going to 2. So each one of our domains is going to one range. So this is a function. Okay, let's look at this one. The domain is 1, 2, 3, 4. The range, since they're all listed, they're 2, 4, 6, and 8. Or we can go 2, 6, and 8. I've seen it written both ways, so it just depends on what your preference is or your instructor's preference is. I would typically leave out the 4, but I have seen the 4 included in the range before, since it is included in our list. This is not a function because 2 is going to a 2 and a 6. So it's saying like a pen is $2 and $6. It just doesn't work. And then if the 2 wasn't going to that 2, let's say we have it written like this, just another scenario. Like this, where the 2 is only going to the 6 and the 3 is going to the 6, this is a function even though the 2 and the 3 are going to 6. So it's almost like saying a pen and a marker are both $6. So as long as one arrow is coming from one of these domains, it is a function. So this one is a function. Okay, where this one is not a function because 2 goes to 2 and 6. So those are maps, or relation maps. Let's look at the pairs, the ordered pairs. Okay, so the domain is all your x values, which the x's come first in this ordered pair. So 1, 4, 7, 0. Now, technically, you're supposed to write this in numerical order where it's 0, 1, 4, 7, but I just write it in the order that they give me. I've seen it written this way. It depends on your instructor. This way is fine for me. So your range will be 3, 5, -3, and 3. Well, I've already written down a 3. There's no need to repeat it. So that's our domain, that's our range. And if you look at our numbers, our values, this is a function because we have one x value going to one y value. Yes, 1 goes to 3 and 0 goes to 3, but that's okay. The y's are the only thing that can repeat. The x's cannot repeat. 3, -2, 4, -4, 7, -3, and 4, 8. So our domain is 3, 4, 7, and 4. I already have a 4 written down. The range is -2, -4, -3, and 8. Is this a function? Well, if you look at this 4 and this 4, one 4 is going to the -4 and this 4 is going to 8. So this is not a function. Or you can simply call it a relation. Okay, so we have a repeat in the domain or in the x's. Another way you can tell if something is a function is by looking at the graph. And this will be called the vertical line test. So if you look at this graph, for every vertical line you draw, there's only going to be one intersection. So this is a function. If we look at this particular graph, if you do the vertical line test, or simply, for instance, look at the y-axis, you only need one vertical line that is false to not make this a function. So if you look here at the y-axis, we have 2 points. So at 0, at x is 0, we have it going to this point and this point. So this is not a function because I can write, or I can draw one vertical line through my graph where it will hit more than 1 point. And that's not a function. If you keep drawing vertical lines and none of them hit 2 points, then it is a function. So only 1 point, it is a function. More than one, not a function. And then the last one is the function from an equation. Most of the time, oftentimes, okay, there's a disclaimer. Oftentimes we can determine just by looking at an equation. here is the general rule that works most of the time, often. If y is to an even power, then the equation is not a function. So for instance, we have 2y equals x to the third plus x squared minus 2. This is a function because y is to the first power. X squared plus y squared equals x plus 5. This is not a function because of y squared. Y is to an even power. Y equals square root x plus 1. This is a function. One particular thing that I have to point out here is this special one. If I write the graph to it, yes, y is technically not to an even power, but if I write the graph out, the vertical line test does not work, because for every x we have, x can equal a positive y or x can equal a negative y. So if we have x equals 3, well, absolute value of 3 is 3 and absolute value of negative 3 is 3. So we'll have two values for y. So this one is actually not a function. Okay, so sometimes you have, so this one's like that not most of the time type of equation. You just have to think, okay, how many y's can I get for an x? So in this case, x can equal a y and x can equal a negative y. So that, or excuse me, is that how I want to do that? No, I'm sorry, that is incorrect. A y can equal, no, I was right, sorry. Yeah, that's right. X can equal a y or x can equal a negative y. Because if we plug in y, we will get an x, and if we plug in a negative y, we will get also an x. Okay, so I was right. I was second guessing myself. So that's it for introductions of functions. So just as long as 1x goes to 1y, we have a function. This concludes this video.